Hey there guys. In this lesson we're going to talk about square and cube roots, and we're going to start out by talking about this term perfect squares. So anytime you square an integer you get what is called a perfect square. So for instance, if we were to take the first 10 integers starting with 1, we could generate the first 10 perfect squares. 1 squared is 1, 2 squared is 4, 3 squared 9, 16, 25, 36, 49, 64, 81, and 100. Okay, so these 10 numbers here that I've written in the blanks are your first 10 perfect squares, and then of course we could keep going as long as we wanted to. Square roots is the opposite of squaring a number. So if I were to take the square root of any of these numbers, any of these perfect squares that we wrote up here in the blanks, we would get the original number. Let's talk about positive numbers for a second. Positive numbers have 2 square roots, and the reason being is that if you think about what numbers you can square to get, let's say, 16. Well, we know that we could square 4 to get 16, but we could also square negative 4 to get 16. Since a negative number times itself is 16, that's in contrast to negative numbers. Negative numbers have 0 square roots. Okay, you can't take a negative number times itself to get a positive number, so that's why we say we can never take the square root of a negative number. The only number that has 1 square root is 0 itself. Moving on to some notation now. So before today, anytime you saw this symbol right here, you probably read that as the square root of. This is actually called a radical symbol in algebra. So oftentimes, instead of saying the square root of a number, you might hear me say radical number. For instance, if you saw this written down, instead of saying the square root of 9, I might call this radical 9. It means the same thing. Okay, it means the square root of x, but we could also call this radical x. So if you see this symbol right here, just radical x, it's used to indicate the positive square root of x. If I put a negative sign in front of the symbol, it is used to indicate the negative square root of x. Okay, so let's jump down to examples just using this radical symbol right here. So number 1, we can read this again as the square root of 49 or radical 49. And so it means what number times itself is 49. Well, we talked about above that there are actually 2 numbers that when we square them we get 49, 7 or negative 7. Whenever you see this symbol by itself, meaning there's no sign in front of it, okay, that means we need the positive version of the number, so it is just 7. Okay, so the only answer to this one here is 7. Number 2, though, we see the square root of 4 or radical 4, but there's a negative sign in front of that. That just means it wants us to give the negative version of our answer. So because the square root of 4 is 2, and there's a negative sign in front of this, our answer is negative 2. For number 3, we have to think what the square root of 196 is. Well, 196 is larger than 144. We know the square root of 144 is 12, so it makes sense that the square root of 196 will be larger than 12. Square root of 196 is actually 14. 14 times 14 is 196, and so our answer here, because there's a negative sign in front of this, will be a negative 14. Number 4, the square root of 484. I want you to pause the video right now and see if you can try to come up with the square root of 484. What number times itself is 484? Once you think you have that, press play to check your answer. Okay, so if you got your answer for this, hopefully you arrived at 22 as your answer. If you aren't sure of what the answer might be, you could always estimate. So think about 400 is a good place to start. Okay, 20 times 20 is 400. So the square root of 484 has to be more than 20. And so if you just start doing some multiplication off to the side, okay, you could try 21 times 21. But you know, because 1 times 1 is 1, okay, this can't be the answer, okay, because your units digit has to be a 4 when you do your multiplication. So that might lead you to 22 times 22, which in fact does give you a 4 in the units place, and when you multiply it out completely, you get your 284. For number 5, we know we need the negative answer of the square root of 81 over 25. Well, the nice thing about the square roots of fractions is if the top and the bottom, the numerator and denominator, are both perfect squares, then the answer to this is just going to be the square root of the numerator over the square root of the denominator. The square root of 81 is 9, and the square root of 25 is 5, so this is going to be just negative 9/5. And for number 6, the same thing. We know the square root of 49 is 7, and we know the square root of 144 is 12, so this is 7/12. Okay, so now we're going to take a look at perfect versus non-perfect squares. So we generated that list of the first 10 perfect squares up at the top of the page, but there are several numbers that are not perfect squares. Okay, so what I want to do right now is just go through this list here, and we're going to circle each value that is a perfect square. We know 9 is a perfect square from our list. 32 was not on our list, and that's because there's no number times itself that gives us 32. The same with 50. 50 is a non-perfect square. 121 is a perfect square, as is 1. 160, it's larger than 144, so it wouldn't have been on our list. But if you take the time to think what 13 times 13 is, for that you'd get 169, okay? And so that means that 160 can't be on the list since you go from 12 squared 144 to 13 squared 169. So 160 is out. 64 is a perfect square. 200 might seem like it's a perfect square, but it's not. There's no number times itself that gives you 200. And 324 may seem like it's not a perfect square. It actually is a perfect square. Okay, if you take 18 times 18, you actually get 324. So it's important to be able to try to recognize perfect squares versus non-perfect squares. And again, if a number is not a perfect square, it's a non-perfect square. So what we're going to do now on the back side is learn how to estimate non-perfect square roots. And so the first thing we're going to do if we get a problem like number 7 that asks us to find the square root of 115 is we're just going to identify what two integers the square root of 115 would lie between. So we know the square root of 115 is between the square root of 100 and the square root of 121, because 115 is between 100 and 121. Well, the square root of 100 we know is 10, and the square root of 121 is 11. So the two consecutive integers that the square root of 115 is between are 10 and 11. Number 8, we have the negative square root of 41. So the negative square root of 41 lies in between the negative square root of 49 and the negative square root of 36. Those are the two perfect squares. Negative 41 lies between. And so we know this lies in between the integers negative 7 and negative 6. For number 9, the negative square root of 206, it actually lies between the perfect squares negative the square root of 225. 225 is a perfect square, and the negative square root of 196, which is also a perfect square. Okay, so the square root of 225 is 15, so this would lie between negative 15 and the square root of 196 is 14, so negative 14 is where negative square root of 206 lies. So now that you practiced that, now we're going to take these square roots here in 10 through 12, and we're going to approximate each one to the nearest tenths place. So the square root of 84, we're going to do the same thing that we did above, and identify what two consecutive integers the square root of 84 is between. So we know this is between the square root of 81 and the square root of 100. So it's somewhere between 9 and 10. So now our job is just to figure out, is this closer to 9 or closer to 10? Well, 84 is a lot closer to 81 than it is 100, so we know that the square root of 84 is going to be closer to 9 than it will be to 10. If it was exactly in the middle between 81 and 100, we could say that was 9.5. Okay, but since it's closer to 9 than 10, then we know it's going to be closer to something like 9.2 or 9.3. Okay, so I'm going to use my approximate symbols here to say that the square root of 84 is not exactly 9.2, but it's approximately 9.2, just a little bit bigger than 9. Okay, next we have negative square root 27. So negative square root 27 is going to be somewhere in between the negative square root of 36 and the negative square root of 25. So that means it's going to lie somewhere in between negative 6 and negative 5. Okay, so think about on a number line where negative 6 and negative 5 are, and then what those what numbers are in between negative 6 and negative 5. Again, right in the middle would be negative 5.5. Everywhere from here to here is negative 5.1, negative 5.2, negative 5.3, and then from here to here is negative 5.6, negative 5.7. 27 is closer to 25, so that means it's going to lie somewhere in this region closer to negative 5. So we might say again something like negative 5.2 would be a good approximation for the negative square root of 27. Finally, we have the square root of 145. Okay, well, 145 is between the square root of 144 and the square root of 169. So it's somewhere between 12 and 13. 145 is awfully close to 12. Okay, so it makes sense that we'd say that the square root of 145 is approximately 12.1, we could say. Okay, so that's square roots. Now we'll go on to cube roots, and we're going to start out by talking about what perfect cubes are. Well, if the square of an integer is called a perfect square, it makes sense to say that the cube of an integer is called a perfect cube. And so let's talk about the first 10 perfect cubes we have below. 1 cubed, or 1 to the third power, is 1. 2 cubed, or 2 to the third power, is 8. 3 cubed is 27. 4 cubed is 64. Then we have 125, 216, 343, 512, 729, and 1000. Okay, so these are the first 10 perfect cubes. The opposite of cubing a number is called finding the cube root of the number. Just like the opposite of squaring a number is called finding the square root of the number. All integers, it doesn't matter whether they're positive or negative, all integers have only one cube root. And think about that for a second. What numbers can you cube or multiply by itself 3 times to get 8? Well, the only number you can multiply by itself 3 times to get 8 is positive 2. What number can you multiply by itself 3 times or cube to get negative 8? Well, you can cube negative 2 to get negative 8. Negative 2 times itself is positive 4. And then if you take negative 2 times itself one more time, you end up getting negative 8. Okay, so all integers, positive or negative, only have one cube root. We also use the radical sign when talking about cube roots. It looks like this though. Notice there's a tiny little 3 up there inside that radical sign. And that means the cube root of x. Okay, the cube root of x. So for number 13, if you see this symbol, this means the cube root of 64. And it means what number times itself 3 times gives you 64. Well, we know from our list up here that 4 times itself 3 times will give you 64. The cube root of 343, the cube root of 343 is going to be 7 from our list here. Number 15, the cube root of negative 27. Okay, well, we know that 3 cubed is positive 27, so it makes sense that negative 3 cubed would give us negative 27. Again, we're allowed to take the cube root of negative integers. Okay, we're allowed to take the cube root, we just can't take the square root of negative integers. That is not allowed. Number 16, the cube root of negative 1 is going to be itself negative 1. For number 17, I want you to pause the video for a moment and think about what number cubed would get you 2,197, or should I say negative 2,197. Once you think you have an answer, click play to check. Okay, so for number 17, negative 13 is the cube root of negative 2,197. Again, if you use some estimating skills, you know this is going to be larger than, well, the cube root of 2,197 has to be larger than 10, since 10 cubed is 1,000. So you might think, okay, 11 times itself 3 times. What would the units digit be on that? Well, the units digit of that would be 1. If you took 12 cubed times the units digit of it would be 2 times 2 times 2, so that'd be 8. 13 cubed, though, think about what the units digit of that number would be. The units digit would be 3 times 3 times 3, which is going to end in a 7. Okay, so a good way to think of large cube roots or square roots is just to think about if you square numbers or cube numbers, what is the ones digit or the units digit going to end in? Okay, so 13 times itself 3 times is in fact 2,197. Finally, number 18, we have the cube root of 512. 512 is on our list here. We know that's 8 cubed, so this is going to give us 8 for our answer. Okay, we're going to practice this a lot more during class the next time I see you, okay, and work on memorizing some of those larger square roots and cube roots. Until then, folks, have a nice day. You're all wonderful people, and take care.